Okay, big moment here in the course. We are now going to start talking about GitHub and start learning about how to use it and the different Git commands that have to do with interacting with tools like GitHub. I feel like that was a clunky sentence, but I guess most of my sentences are clunky anyway. So this is our first taste of GitHub, the Essentials. We're going to start by talking about things like what does GitHub do, who uses it, and I'm going to show you a command called git clone, which really doesn't have to do with GitHub. It's not intrinsically linked to GitHub, but it is relevant to this section. So that is also critical, as well as registering for GitHub and setting up our SSH keys. This is critical. We're going to be using GitHub, and we want to set up an SSH key so that we don't have to enter a username and password every time we try and connect to GitHub from our terminal or from Git. That's probably the most annoying part of this section, is setting up those keys. It's not the end of the world, but it's just a bunch of steps you have to follow. And then we get into the meat and potatoes, creating GitHub repos, working with remotes, using the Git Push command. So we'll see a couple of new commands, git clone, some remote commands, and Git Push in this section, but pretty much everything here is critical. If you plan on using Git alongside GitHub, you could just skip all the GitHub stuff if you wanted to, but GitHub is so commonly used both by individuals, but also in enterprise situations, open source projects, big companies. I would not advise skipping it, so I'm marking everything as critical. All right, so let's get started with GitHub. All right, so let's start with the obvious question. What exactly is GitHub, or what does it do? There's many answers to that question because GitHub over the years has really evolved and added on a bunch of features. But the core mechanic, the single thing that GitHub is known for, is that it's a hosting platform for Git repositories. GitHub allows us to put our Git repos in the cloud. We can access them from anywhere, we can share them with people, and we can collaborate with people on Git repos. So GitHub has a bunch of features built that have to do with collaboration and discussion about Git repos. So I showed this slide very early on, but I just want to return to it. There's an important, huge difference between Git and GitHub. Git, hopefully you're familiar with by now, is a version control system that we run on our machines locally. We don't need the internet. We don't need an account. You could go your entire life working with Git and never using GitHub. GitHub, on the other hand, is a website. It's a hosting platform for Git repositories. You need the internet to access it. You need an account. It is completely, I don't want to say completely separate from Git, because it is a hosting service for Git repos. But Git itself is completely independent. So imagine I'm working on a video game, a mobile game that I'm developing on my machine, and I'm using Git to track it. I have a couple of commits. Let's say there's like a couple hundred. Those 3 you're seeing on my machine are just to fit in the diagram. And I can make a GitHub account, make a GitHub repository, and push my local code, that repo from my machine, up to GitHub. And I could do this for a couple of reasons. One, I just want to back things up. So I keep doing more work, and I can push those changes up to GitHub. So now GitHub has a record of my repository. So maybe there's a house fire, a horrible tragedy. I get a new laptop. I lost my old laptop with the repo on it. Well, fortunately for me, assuming I kept my GitHub up to date, I can go to GitHub and get that code and pull it down to my machine. So that's kind of I won't say rare, but not as common scenario. What really is great about pushing my code up to GitHub is that I can collaborate. So maybe I decide I need to bring in, another engineer over here on the left, and I don't know what her name is. Let's say Zelda, and then I bring in a graphics artist, pixel artist over here on the right. His name is Link. So I need their help. So using GitHub, they can all clone or they can all get access to this repository on their machine. And then they can make contributions, put them up on GitHub, and then we can pull them down and get those latest contributions, those new commits. And this allows us to collaborate. And maybe eventually, if my game's a hit, we're talking about dozens or hundreds of collaborators. So this is really where GitHub shines. It's important to know that GitHub is not the only option for some of these features. Specifically for hosting repositories, there are other options like GitLab, Bitbucket, but the truth is that in recent years, GitHub has just completely obliterated the competition. It's now become the world's largest host of source code. In early 2020, they reported having over 40 million users. These days, it looks like over 56 million in 2021, just from their own marketing page, which we'll come back to. It's really a lovely marketing page. And the last slide here on GitHub that's very important is that it's free for our purposes. So unlike a lot of subscription platforms or websites where the free tier is just garbage, or it's just supposed to like lure you into paying more, right? Where maybe you have a very limited set of features, and if you pay $10 a month, then you can actually use this in a useful way. That is not GitHub's model. GitHub offers paid tiers, but they're largely oriented towards enterprise, towards companies. For individuals, for developers, the free tier gives you pretty much everything you would need. Unless you are creating some incredibly popular tool, an open source project that's like used by millions of people, in all likelihood, you'll never need to subscribe to GitHub. So I can show you the different pricing tiers here, right? Here's free. There is a team, there's enterprise level. But with this free level, we have unlimited public and private repositories, unlimited collaborators. There's these things called GitHub Actions we'll talk more about. So there are some distinctions there. You pay for more actions or more minutes a month. And then there are some security features larger enterprise companies might want, single sign-on, this advanced auditing, but we really don't need to worry about that. We're focused on just the core mechanics of GitHub. It's all here for us, which we are very, very thankful for. Somewhat rare in the world of subscriptions. So I'll end off by just scrolling through their beautiful marketing page. I really love the illustrations they have. You can see some stats about how many people are using it. 72% of Fortune 50 companies. It's really grown both in market share for just open source development and random developers like me, but also in large companies. So tons of big companies use it. I'd say it all boils down to this: give your code a home in the cloud. But there are many other features. It almost acts as a social network for Git repos where you can chat, write comments, approve, disapprove, suggest changes to projects, merge code in, reject code, call attention to certain lines of code. Then there are some other things that don't necessarily have to do with Git repos, but are kind of adjacent, like these interactive developer environments. I think, what do they call it? Code spaces, that's new. GitHub Actions we'll come back to later on. Additional features like automatically scanning your repositories and looking for common vulnerabilities and letting you know ahead of time. And a whole bunch of other things. So let's end with that. What a beautiful illustration. Okay, so that's it. GitHub does a lot, but for us, what we care about is the fact that it will host our repositories and help facilitate collaboration. Whew. In this video, I'll do my best to keep this quick. I want to talk about why you should use GitHub or know how to use it, and not just the basic reason of, backing up your code or being able to collaborate, although obviously that's a really important part of using GitHub and one of the main reasons people want to use it. But there are other reasons, especially if you're part of the, greater developer community. Things like if you're looking for a job down the line or trying to meet potential mentors, there are other reasons. So collaboration is 100% one of the most important reasons to use GitHub. If we take a look at some projects, you can see there are certain repositories that have 1,500 plus different contributors working on the same project. So that's pretty amazing. And there are repos with thousands and thousands of contributors. But the first reason I want to focus on that maybe is slightly different than just a generic collaboration is good, is open source projects. If you're not familiar with the term or need a recap, open source projects are projects where the code base is available, not just to look at, but also to make contributions to fix bugs, to discuss with a community, a greater community of people, usually the users of the product. Anyway, GitHub has become the home of open source projects on the internet today. And so if you ever plan on working on open source projects or contributing or starting your own, GitHub is the place to do it currently. And if you have never made contributions, you might want to consider making open source contributions, especially if you plan on looking for a job at some point. It's great proof that you know what you're doing. So just a couple of open source projects, things like React. Very, very, very popular tool. JavaScript library. It's all on GitHub, and lots of people have made contributions. So it's not just the people on the official React team at Facebook. Same thing with TensorFlow, just to give another example. So a machine learning framework, 100, I know that's how many people used it, almost 3,000 contributors. And that brings me to the next point, which is GitHub can give you, as a developer, it can give you exposure. It can give you, I won't say notoriety, but if you do contribute to open source projects consistently, you are going to run into people and sort of make friends, or at least GitHub friends, because you're having conversations, you're talking about features and lines of code together. Additionally, employers will often look at your GitHub profile. So I'll just show you one or two of those. This is my friend Carly, who was recently looking for a job. You can actually see her contributions here stopped when she got a job and started working on that job full time. But we've got things like her repositories she's worked on. If I'm thinking about hiring her, I might go take a look at one of them. And what is this? Oh, this is like a marketing website for a concert series. And then we can take a look. Okay. So that's just a very simple demo of how, your GitHub profile can act as a bit of a resume for your code. So we can take a look at all our different projects. Similarly, here's another friend. I can see recently, just this in January, he contributed to Material UI, a very popular large front-end component library. And if I was thinking about hiring somebody and I saw that, it's not an instant yes, but it's a good sign. And then the last reason that I'll list is that GitHub can help you stay up to date. It has some sort of vaguely social networky features. And if, let's say, you're a React developer, you can stay up to date on changes coming to the React project. You can stay sort of active in the conversation and learn more about, when that next massive update is coming that is going to change everything. You can even anticipate it. If you're active on GitHub, you can set up notifications and you can be the first to know. Anyway, for us, the main reason that it all comes back to is collaboration, getting our code up on GitHub. But these side effects are nice too, right? Being able to work on open source projects is great in general. But specifically, if you're looking for a job, it can be a great idea, a great sort of resume builder. You can gain exposure, you can meet mentors, and just sort of have a presence in the coding world. And you can stay up to date on repositories and upcoming changes. So the first thing we're going to cover is cloning. Cloning is a really important part of working with remote repositories. In fact, it's such an important thing that we do in Git. If we go to the documentation under reference, all the commands are grouped together, like the basic snapshotting commands, adding and git status, git commits, branching and merging, they're grouped together. But then up top, there are two commands side by side, getting and creating projects, init and clone. So we've seen how to use git init to create a new project or a new repo from scratch. We've done that for every repository. But git clone does something different. Git clone actually goes and gets a repository that is not on your machine, and it brings it to your machine. It basically downloads the contents of a repository based upon some URL that we provide. Typically, that URL will be from a service like GitHub. And in this course, and 99% of the open source projects out there, it will be a GitHub repository that you're cloning, but it could be something else, Bitbucket, it could be a self-hosted repository. Git does not care. The command git clone is part of Git, it's not part of GitHub. So here it is, git clone, and then a URL. And that URL is where Git will go and retrieve all the relevant information for a repository from. It will copy the files to your machine. It initializes a new repository on your machine. So that gives you access to the full Git history of whatever project you're cloning. And I'm going to demo this in just a moment. So as an example, there's some repository on GitHub. Let's say it's, it's React, or it's a Flappy Bird clone. It's some game on GitHub. I want the source code and the Git history. So if I run git clone with the corresponding URL, whatever that GitHub URL is for that hosted repo, Git is going to go fetch all of that and bring it down to my machine. I'll have the full history, all the commits, all the files. So I'll go ahead and demonstrate this. Here's a GitHub repository that I don't have. It's for the game 2048, which some of you probably know. This game, very addictive. It's, I don't know how many years old now, but anyway, it's just a JavaScript, some HTML, some CSS, that it's a game. You can open it up and play it in your browser. So if I want the code for that and I want the full Git history, of course I can see it on GitHub, right? That's what GitHub is doing for me here as a user. I can view this URL. I can look at different commits, 180 commits. I can see who contributed. I can read about it. I can take a look at, the index HTML file in the browser. But I'm going to clone this URL. One option is just to copy this URL right here. Another option on GitHub is to click right here, and it's going to show me the clone URL, which is the same thing as we see up there. I can click this button. I can, Command C, however you want to get that URL. I'm going to get that URL. And by the way, this repository link is in the resources with this video. If you want to try this, definitely recommend you do. Now, I'm going to go over to my terminal. The first thing you always want to do when you're cloning is make sure that you're not in a repository, just like when you run git init. So I just like to do git status. Okay, we're not in a repository. And then wherever you run git clone, that is the place, that folder, where Git is going to create a new folder for you. So I'm in a folder called, what is this? Actually I meant to be in this folder cloning. So now I'm in a folder cloning. There's nothing in here. It's going to make me a new folder when I run this command, git clone, and then I paste the URL. That's coming from GitHub. I don't have anything from this URL. I don't have this repository on this machine. I'm not in a Git repo. But when that finishes, and you will need internet for this, when that finishes, we see a new folder. That was not there before, right? I typed ls, there was nothing. If I go into that folder and I type ls, okay, I've got a whole bunch of stuff, right? I've got index HTML, a JavaScript folder, style folder, some other stuff going on. And it looks like this is a Git repo, right? If I type git status, yes, it is. If I type git log, I can see the full history of commits. See all that stuff? That's all, it came from GitHub. I can see all the commits and who made them, when they were made. There's, all the code here. I can open it up and take a look. I can even run this. And there, this is actually running. This is not the hosted version. This is running from my machine. You can see here. And there we are. I could play around with it myself. I could change the styles. I've opened up the CSS, main.css, and I could do something like, is there a background? What are we dealing with? The background color somewhere. There we are. Let's make that some form of green or olive. Sure, olive, just like that. So pretend I've tweaked a whole bunch of things. I can see those changes, right? This is all just for me to experiment and play around with locally. Although in the next couple of sections, I'll also show how we could make changes and then try and contribute. Try and share these changes with the owner of the repository. Try and suggest, maybe not this, but maybe there's a bug that someone's identified and I volunteer to fix it. I would need to clone the repository. Whether I'm just messing around and breaking things and playing and changing colors, whether I'm trying to understand how something works, or whether I want to make contributions, I need to clone. So that command, git clone, it's pretty simple, right? Just git clone and then a URL. Make sure you're not in a Git repository when you run it, because it creates a folder, but in that folder, there is a Git repository that's been initialized, and it has the full history of the project. I'm just showing it to you in Git Kraken very quickly. This is the cloned repository, and we can see a lot of commits going on as I scroll, a lot of different branches over time, a lot of different contributors. And I could take a look at any of them, right? I could go all the way back to the beginning. Oh boy, look, initial commit, basic styling, the very basic stuff, like add win condition so you can win the game, all the way up to things up top where other developers have contributed. I'll just show one more example. This is another GitHub repository. This one is just a list. It's a list of companies that hire without whiteboarding interviews, without the bad computer science trivia questions that don't actually test your abilities as a developer. It's open source. People contribute, different companies that are on here. If I want this repository for whatever reason on my machine, never mind the fact that it's probably easier to view it here. But if I wanted to contribute and add, I could copy this URL, right? Or I can click here and copy that. They're the same URL. Go to my terminal, which is somewhere, there we are. Make sure I'm not in a Git repo, and I am right now. So I'm going to back out, and now I'm not. I type git status, I'm not. Git clone, paste the URL. It takes a moment. This one's a bit larger. And then I have a new folder, hiring without whiteboards. Git status inside, yes, it is a repository. I type ls, we can see all the files here, and I type git log, and I can see all of the contributions, all the individual commits. There's quite a bit here. Let's do a one line. Okay, and then I can scroll through all of them. I could open this in Git Kraken and show you the same thing. I have the full history for that entire repository on my machine. I didn't create the repository, right? I just cloned it using git clone. Great command. Excellent, excellent, great command. Remember, it's a git command. It is not tied to GitHub. One other thing about git clone, something that I do get asked frequently from beginners is, do I have permission to clone this stuff? The answer is yes. If you see it on GitHub, if you actually can see it, you have permission to clone it and do whatever you want with it in terms of tweaking the code. And that doesn't mean you can turn around and, resell it necessarily, depending on how it's licensed. But you definitely are able to clone that repository to your machine. So anybody can clone if it's a public repository. And if it was private, you wouldn't be able to see it anyways. You wouldn't, right? You wouldn't know the URL. You wouldn't be able to go to it on GitHub. But if you can see it on GitHub, copy that URL, you can clone it. You don't need to be an owner or a contributor. However, you're not allowed to just push up your own changes. We haven't talked about pushing, but once we get there, you can't just push changes up to a repository that somebody else owns. There's a whole workflow for suggesting changes, for becoming a contributor, but you can't just take over someone's repository, clone it, delete everything, and then push that up to GitHub. So that's very, very important to understand. If you see the repo on GitHub, you can clone it. Now, everything I've said has been cloning, or everything I've demonstrated has been using git clone with GitHub repositories because GitHub is so popular. It's the standard place to host Git repositories. But remember that git clone works with any hosted repository. In fact, if you go to the documentation, the Git docs for git clone, there is no mention of GitHub anywhere on here. So even if that's where a lot of people are using it, is to clone GitHub repos, that's just how people are using it. That is not the nature of the command. Instead, it works with any hosted repository, whether that's something that you're serving yourself, like maybe a company has their own internal server with a hosted repo, or maybe we're using something like GitLab. So I actually struggled to find something that was public that we could clone that was not from GitHub, but here's an example. This is a project on GitLab. It's just called Sample Project. It's really just for demonstrating how to clone something on GitLab. So you don't need to go through and follow along with this, but if you want to, I'll include the link. I'm just going to copy the URL, and then I'm going to go to my terminal, if I can find it, over here. I'm going to make sure I'm not in a repository. So I am. Back out. Now I'm not. And I run git clone. And this time it's not a GitHub URL, right? This is entirely different. And it looks like it worked. I have a new folder called Sample Project. This is not exciting on the inside, but you can see I'm in a Git repo. I'm on the master branch right now. Git status, here's git log. There's 4 or so commits in there. All right, so just proof that git clone is not tied to GitHub. It's just a native Git command. Most of the usage you'll see online is with GitHub, but it will clone any hosted repo. So the next step, a very important one, is to register for GitHub. So go to github.com if you don't have an account yet and click sign up. So then you'll need to come up with a username, an email address, and a password. Make sure that you use a real email address because you will need to verify the email. And it's helpful, things work better if the email address you use here is the one that you configured very early on in the course. If you remember, we did this. Let's see, git config user.email. So I'm actually using a special email that GitHub gives me, but basically we want Git to use the same email address here that we use on GitHub. I use this weird no reply email just so that I'm not like publicly blasting my email address in every Git commit or in every video I do using Git, but it works best if whatever your account email is also set up locally in your Git config, and that just helps GitHub know who you are. When you push up code, it knows to use your profile and your image and sort of track your work. Anyway, so sign up, use an email address, your username, and then the second step, once that is done, is to configure an SSH key. So without going into too much detail, SSH, I believe it stands for Secure Shell, is this protocol that allows us to be authenticated without having to write our email or our username and password every single time we want to interact with GitHub from the command line. So what we need to do is generate one of these SSH keys and then tell GitHub about it. And to do that, we're going to follow the instructions on GitHub that go into detail about how to do that. So it depends on the platform you're on. But the first step is to check if you have an SSH key generated already. And all you do to figure that out is run this command here. So you can just copy this command. You don't want that $sign. And this is going to show a whole bunch of, it may show a whole bunch of existing files in a directory called .ssh. If nothing is in there, or rather if you don't see any of these, idrsa.pub, idecdca.pub. These are all different hashing algorithms. If you don't see one of these, or you just want to make a new key, if you're brand new to all of this, you likely don't have any of these files. It's no big deal. All we need to do is generate a new key. So this is where things diverge a bit if you're on a Windows machine versus a Mac. I don't think the differences are that significant, but definitely do it following the tutorial here on GitHub. Don't use this video as the source of truth. Things change quickly. I'll include it as one of the resources. So I'll go through this process. I've already set up an SSH key, but I'll do the same thing. So we're going to copy this right here, and then we put our email in there, and that will act as our label. So I'm going to go to my terminal, and I'm going to run this, and then in quotes, I'm just going to use this email here. This is the one I use for Git and GitHub. Okay, and then it's going to ask me for a file where it should save that key. So this is the default file name and the default location in this .ssh folder. If you just hit enter, it's going to use that. You can also come up with your own file name if you want. However, all the GitHub tutorials use this name, id_ed25519. So I'm just going to go with that. So I'm going to hit enter and then enter a passphrase. So you can type that passphrase and then enter the same passphrase again. All right, so then it tells me that my identification has been saved in this file, and my public key has been saved in a similar file, but it ends in .pub. It's the public key. I'm not going into detail explaining how this stuff works because it doesn't really matter at this point. We just want to get it set up. So the next step is to then add the SSH key to the SSH agent. So we're going to copy this line if you're on a Mac. And there are some instructions depending on the Mac OS operating system. I guess that's what OS is. Depending on the version that you're running, you may need to make some additional changes. So I'm going to try this here. Okay, so that looks like it's working fine. So the next step on a Mac is to check if we have this file called config in the SSH directory, so we can see if it exists. And if it doesn't exist, you can run this command to make it. So if you get this line that says it does not exist, try this one to make that file. And again, this is only if you're on a newer Mac. And then here, we need to open that file and then put this right here, just copy this and put that in the file. Now, if you gave your file name when you generated the keys, if you gave it a different name from the default, you'll need to reflect that name here. But I'm just going with what they have on the documentation. So I'm going to paste that in. Hopefully you can see this. And save. So that was the name of my file. If you remember right here, this is what I said to save it as. I just hit enter. So that matches this right here, coming from the GitHub docs. Also, if you elected to use a passcode when you generated the key, you'll want this line. And if you did not use a passcode, you don't want that line. Now, the final step here is, well, the final step before we go to GitHub is to copy this line, which is to add our key to something called the SSH agent, which we just started up. And if we do this, again, you need to make sure you're using the correct file name that matches the file name you generated. But again, this is the default. So if you didn't deviate, this is all you need to do. We'll run this line. Okay, identity added. So now the final step is to go to GitHub and add that SSH key to the GitHub account. So what we need to do is copy the contents of the key that was generated, the public key. So again, just copy this line if you're using the same name and you didn't modify it. You won't see any outputs, but this command pbcopy copies the output of this into your clipboard. So on the clipboard right now, I have this key here. So I got that, I have access to it. And now I need to go onto GitHub and go to my profile, the little profile photo up top, and then go to settings, I believe is what it is. Super zoomed in here. Here we are. And then I click on SSH, and then I'll add a new key. So I'll just demonstrate this. I go to GitHub. Here's my profile. I'm going to go to settings, and then SSH and GPG keys. And then I'm going to click new SSH key, just like that. And then I'm going to paste this in, the thing I copied from the clipboard over here, or copied to my clipboard, and then give it a title, just like laptop, for example, or my key, it doesn't matter. And I'm going to add it. All right, so we should be good to go now. I know it's an obnoxious process, but once we have it done, you really don't ever have to do it again, at least not on this machine. With that said, I'm gonna do it again after recording this video, but we should have the key set up and we'll know if it works or not when we try pushing in the next couple of videos. Okay, so let's talk about how we actually get our code up on GitHub. How do we take a local Git repo on our laptop, and how do I connect that in some way to a hosted GitHub repo? How do I connect them? How do I set up the repo on GitHub? And then what do I do on my machine to tell it about the GitHub repo? Well, there's really two different approaches or two options that I'm going to walk through. In this video, I'm just going to talk about both of them and just explain how they work, and then we'll dive into actually doing them. So the first option, called option 1, is if you have an existing repo on your machine. If you have something that you've already been working on, it already has Git history, you already have code, whatever it is, and you want to get that on GitHub, these would be the steps that you follow. You create a new repo on GitHub, then you connect your local repo by adding something called a remote. We'll go into that. So you add that remote to your local machine, and then you push your changes up to GitHub. So here's some diagrams. If I have something I've been working on, whether it's just a day of work, an hour of work, an empty repository that I've created, or years of work, whatever it is, if it's on my machine and not on GitHub, I go onto GitHub and I make a new empty repository. I'll show that in just a moment too. So once I make that new empty repository, then what I do is tell my computer, specifically tell this Git repository, about the GitHub repository. And then I can push my code up to the GitHub repo. The other option is if I don't have anything done yet, I don't have a repo anywhere. I know I want to start a project, and I know right out of the gate that I also want to use GitHub alongside Git. If that's the case, I can start on GitHub, make a new repo on GitHub, and clone that down to my machine as an empty repository. Instead of running git init, I can clone down my GitHub repo that's empty and start working in that repo, and then push it up to GitHub. And if I do it that way, I don't have to manually connect my local repo to my GitHub repo, because if I clone this repo from GitHub, it automatically is connected to that GitHub URL. So some diagrams to illustrate that. I don't have any repositories yet, either on GitHub or on my machine. And I start by making a new repo on GitHub, which I'm visualizing as this empty container. And then I clone that down to my laptop. And because it came from this clone, it automatically knows about this GitHub URL. So now I can do my work locally and push it up. I don't have to connect them in any way. But I'm going to actually start by showing you the other option, option 1, because you may have some existing code. I mean, we certainly have existing repos from the course. None of them are very useful, but we have existing repos, right? We've been working with Git, and let's talk about how to get that on GitHub. So to do that, the first step is to make an empty GitHub repo. So if you want to follow along, start by just picking some Git repository that we've made or that you've made that you want to get on GitHub. So it doesn't have to be something that you make public. And it doesn't have to be something that you keep up there, right? You can delete it or get rid of it immediately if you don't want people to see it. So we've done quite a few different repositories. Why don't I just take that really simple book repository, my first novel. All right, so it's a disastrous repo. I'd like to get all of this up on GitHub. All right, all this history, all my files. One more time, this is what I'm dealing with. So whatever you have found, if you have a repo you want to follow along with, the first step is to go on GitHub. So once you're signed in, and create a new empty repo. And there's a couple of buttons to do that. One is just this green button if you're on the home page, new, or if you're somewhere else, like I'm on Marketplace, if I click the plus, new repo right there, then I see this page, create a new repository. So we need to come up with a name about GitHub demo novel or something like that. This is just a name that we'll use to identify it on GitHub, right? It doesn't have to match anything from our actual repository that we have locally, but we don't want spaces. It will automatically add dashes for us. I don't know, I just put them in there myself, but we don't need to do that. You don't really need a description, although you should put one in, especially if you plan on having other people see this repo or discover it. But we will talk more about that. To keep this short and simple, I'm not going to put a description in there, and then we can decide if it's public or private. Now, I'm going to keep this public in case some of you want to take a look at the repo, although, frankly, for the contents of this book, it's probably best for my reputation if I do make it private. That just means that if someone looks at my profile, if they search, they're not going to find this repository. They don't have access to it. But if it's public, anyone can see it. Okay, and then I'm not going to touch this. We will come back and talk more about these files later. I'm just going to click Create Repository. And did I click? I might have not. Okay, I guess I didn't click. And okay, we now see this page here. So my username, Colt, / and then the repository name. And then inside of it, there's not really anything to look at right now, except for a couple of instructions. All right, so I'll stop here. We've made an empty GitHub repository. Our local repo knows nothing about it. They're not connected in any way, but that's going to change in the next video. All right, so the next thing that we need to do is take this empty GitHub repo that's in the cloud, it's not connected at all to our local repo, and somehow configure our local repo so that it knows about this GitHub repo. Well, the way that we do this, whether we're using GitHub or any other service that hosts a repo, is to set up a Git remote. So a remote is really just a fancy name for like a destination URL. It's a URL that we tell Git about, and we give it a name. It's just like a label for a URL that we can then push code up to or fetch or pull down new code from. So we'll learn about those commands once we set up a remote. So an easy place to start is with this command, git remote or git remote -v. They won't do anything except list to you the current remotes that you have in a repository. So in our repository, we have not configured any remotes, right? At this point, we haven't done anything with remotes. If I type git remote or git remote -v, I'm in my book, my first novel, The Great Gatsby repo, nothing. But if we actually go to any of the repos that we cloned, if you followed along, I cloned this 2048 repo from GitHub. Remember this one? It has a whole bunch of commits. It's that addicting 2048 game. Anyway, if I type git remote in here, I see something now. Origin. We'll talk about that in a moment. Let's do -v so you can see the difference. If I do -v, I think it's verbose, we see the name of a remote and the corresponding URL. So I didn't set this up, right? All I did was git clone and then this URL. And by doing that, Git made me a local repo. It put all these files in here. It gave me all the history. And it set up a remote that said the original GitHub URL that this repo came from, that it was cloned from, is right here. So by setting this URL up, this remote origin, it gives me the ability later on to say, hey, Git, is there any new code on that URL? Is there any new updates? Or if I was a collaborator, hey Git, I'd like to push up my new 10 commits. It's kind of a lot to push up, but I'd like to push my new 2 commits that I did today up to origin. Okay, so I'll just show you one more example. If I take a look at, let's see, sample project, that was the one that I cloned in the second video I did. It's really very simple, nothing in it. It came from, was it Bitbucket, I believe? If I do git remote -v, no, GitLab, sorry. It was a non-GitHub repository. The same thing is true, right? I have a remote called origin automatically set up. I didn't do that. And it's set to whatever I cloned, or whatever the URL is that I cloned it from. Okay, so we did not clone this repository, right? My first novel, we ran git init. We created it from scratch. So there are no remotes. But we can make a remote using this command. Git remote add, and then a name and a URL. So this is a way of telling Git, hello Git, please remember this URL using this name. So whatever the name is that we provide. So a really standard name is origin. So git remote add origin, and then some GitHub URL for a GitHub repo that we've created is telling Git, hey, here's a URL. I'm going to call it origin. You remember that. Anytime I refer to origin, I'm talking about this URL. So the term origin, it's just a conventional Git remote name, but it's not special in any way, no magical powers. It doesn't have any secret abilities. It's just a name for a URL. You could rename them. You can come up with whatever names you want for remotes, but origin is what you'll see all the time. Similar to how the master branch is a default name, or the default name for branches, you can change it to anything. So in the same way that master is just a name for a branch, origin is just a conventional name. You'll see it a lot, but it is not somehow special. It's just a name for a remote. So we could instead add a new remote for the same URL, but instead call it my GitHub URL, or LOL, or chickens are my friends, whatever you want. But I would suggest origin because it's what you'll see the most, and then a URL. And actually, if we go to the GitHub repository that we created that's empty, we see some instructions. It's telling us, first of all, if you've done this thing before, this kind of thing before, here's a URL. That is the URL for my repo. I hope this goes without saying. You should be using your URL, right? Not my repo, because you won't have permission to push your code up to my repository. So I hope you made your own if you're following along. Then it's telling me, if you don't have a repo yet on the at all locally, follow these instructions. But I do. So I'm not following those. This is what we want. Push an existing repo from the command line. And take a look at the very first line. Git remote add origin, and then the URL for my Git repo. It's the same URL we see here. So I'm going to copy that, or just copy the whole line. It doesn't really matter. I guess I'll separate it out just to hit the point harder here. So I'm on the My First Novel repository. Right now, no remotes. Now, git remote, add, and then a name. I'm going to go with origin. It's conventional. And then this GitHub URL, whatever your GitHub URL is for that repo. Now, nothing really happens, but of course we can check our work with what we just saw, git remote -v. So hopefully we see origin set up to this URL, and it is. So that's kind of all we need to do for now. We've connected, we've told our local Git repo about a GitHub URL called origin, or that's the name that we'll refer to it by. So in the next video, I'll show you how we can push code up to origin. I just want to emphasize one more time, it's just a name for a URL, a remote destination. And this is not super common, but if needed, you can rename a remote with this command, git remote rename the old name space new name, and you can get rid of a remote with git remote remove and then the name that you're trying to delete. And later on, we'll actually see that it's somewhat common to have multiple remotes, especially when you're working on open source projects. We'll talk about workflows and how that would work when we get to that section. Okay. All right. So we have one more step to get our code up on GitHub. We just need to push it up. So if you remember option 1, what we're following here, option 1 out of 2, is to create a new repo on GitHub, which we've done, connect the local repo by adding a remote to our GitHub repo. We just did that in the previous video. Now we need to push our changes up. So we have our existing repo. I'm doing that stupid Great Gatsby novel fake repo. I created an empty GitHub repo, and then I set my remote called origin so that it points at this empty GitHub repo. So the final step is to push up. So we do this using the Git Push command. Again, this is not GitHub specific, though everything we'll be pushing to will be a GitHub repo. But the Git Push command is a Git command. It existed long before GitHub. And there are many other places where you can have a hosted repo that you can push to. So it works with any remote. Basically, the syntax is git push, and then a remote. In our case, we just have one, which is origin, but we can have multiple. So we have to tell Git where we're pushing, what's the destination repository, and what branch to push. So, we might have a really large repo with a ton of branches. Like, actually, we don't have a ton here, but we've got a couple. No, just 2. Oh, well, this is because this repo was created before we went into branching, but some of our repos have 7, 8, maybe 10 branches, and you may not want all of them on GitHub, or you may not want to push them all at once at least. So when we push, we call out a particular branch that we want to send to GitHub. Often that will be your master or main branch, but you can push any branch up to GitHub, and I'll show you that. So this is a really common command, git push origin master, though it is becoming slightly less common as more people rename their master branch to main. If you recall, we talked about this early on when I introduced branching. It now comes up again, master versus main, because GitHub, as I mentioned at the end of 2020, decided to make the default branch name on a GitHub repo main instead of master. So their instructions tell you to add a remote called origin, but then rename your branch, the master branch, to main, and then push main. So I will do this as well in a separate video. I will show this process. It's the exact same process. We rename a branch, we name it main, and then we push up main. But I'm going to start with master just to keep this as simple as possible because we have a master branch, right? We've been working with the term master, so we'll start there first. Okay, so I have this remote called origin, as we already discussed, git remote -v. We see what it's pointing to. And it's always a good idea to see, what we have. If we have any uncommitted changes, that won't go up. Otherwise, we're ready. We're going to do a git push, and then origin is where we're pushing to, and then master is the branch we are pushing up. Okay, so this is what our GitHub looks like right now. I'll refresh. There's nothing here except these instructions. This is the repo. But now I'm going to push, and there's going to be a substantial change. And remember, oh gosh, I put images in this repo, didn't I? Well, that's why it's taking a little bit. As you can see here, I have some images in that mood board. Usually you don't include images or at least not large images like I have, but it finished up. Most repos are going to push way, way, way faster than that because they're usually just code. So I'm going to refresh the page. And now we see something entirely different, right? We don't see those instructions. Now we see our file contents. So chapter 1, chapter 2, chapter 3, characters, outline. We see different commits. I'll actually do a separate video where I walk through what we see, but we also have access to things like contributors. We can see there's only one branch, which is the master branch. And I can take a look at chapter 1, for example. Here's the contents of chapter 1. Okay, so we have our code up here. Now what I want to show you is that we can push any branch, right? I talked about pushing master because that's what we have on this project. But if we make a new branch, which I'll just make, what should my branch be called? How about empty or nearly empty? I switch to that branch, and I'm just going to delete pretty much everything in here. I'm going to delete mood board for sure. So that's actually rm-rf to get rid of that. It's a folder. And I'll rm, how about all chapters? So chapter 1, I'll just leave the outline and the characters. So now, whoops, this is all we have. I'm on a branch though called empty, so I'm going to add everything and then git commit, delete most things. Alrighty. Now, if I want to push the code that I just changed, I want to push my last commit from this branch. Remember, I'm on the empty branch. I need to push the empty branch. So let me illustrate that. Here, I've got some diagrams. What we just did was we pushed up our master branch to GitHub. So there was nothing on GitHub. I pushed up master. Whoops, I went too far. Git push origin master, assuming our remote is named origin. Now, in this diagram, I have a second branch called new feature. I'm going to push that up. Git push origin new feature. In our case, our branch is called empty. So git push origin empty. I don't have to be on this branch, by the way. I happen to be on it, which is very common, that you're taking a look at what's on a branch and then you push it up, but you don't have to be on it. So git push origin empty. And remember, if it asks you for your password, not a big deal. Put your email and password or your username and password, but go back and check out the SSH video so that it doesn't have to keep bugging you, asking you for a password every time you push. Okay, so now I'm going to refresh. And it doesn't look like much changed, but now we have two branches, and we can see the two branches here, master and empty. And I can switch between them. And this is my empty branch. I'm just viewing it on GitHub. And you'll see it just has two files, right? Go back to master, and I have a whole bunch of stuff. Okay? So I'm going to just go through this process one more time just to make it very clear. I'm going to go back to master, git switch master, and let's make some changes. We'll do some new work here. How about chapter 4.txt? Alrighty, and I'll just leave it blank, I guess. And I'm going to add that. So git add chapter 4, git commit, begin chapter 4. Okay, pop quiz. What's on my GitHub? What's the most recent commit that I'll see on the GitHub repo? Nothing has changed on GitHub. It's still exactly the same. If we're looking at the master branch, nothing's changed. If we're looking at the empty branch, nothing has changed since we last pushed. GitHub doesn't just stay in sync automatically with my local repo. I have to push. So why don't I push up that commit? Chapter 4, begin chapter 4. Now I said push up that commit. We don't select a specific commit. We push an entire branch, as we've talked about. So I made that commit on the master branch, so I'll push that up. Git push origin, the only remote we have right now, origin master. Now if we head over here and refresh, we see, first of all, my most recent commit, begin chapter 4, 1 minute ago. We also see the actual updated contents, right? Chapter 4.txt is right there. Okay, so in the next video, I'm going to kind of walk through a GitHub repository, show you how we view the commits, the branches, diffs or changes, all that stuff. And then we'll get some more practice with pushing, and we'll talk about renaming to use the main branch. Okay, so I'll keep this short. Now that we have some code, some repo up on GitHub that actually has contents, it's not empty anymore, even if the contents absolutely suck, they're garbage, like this repo, I want to walk through what we're actually looking at. So, of course, we see the files, the actual contents here, right? We've got chapter 1. We can look at that and inspect and read, sure. We can also switch branches. So we only have 2 right now. Empty, which was that branch I made where almost everything was deleted, and then master. Notice, if I go back to empty, it tells us, this branch has 1 commit that master does not have, but it also is missing 1 commit that master has. We can see here, the most recent push to this branch happened 4 minutes ago. And we can also, if we go back to master, it doesn't really matter, we can see the commits listed here, the most recent commit that affected each one of these files. So when I made chapter 4, that text file, that was part of the commit begin chapter 4. When I added headings to files, you can see that's the most recent change to this and this one, and the outline. If you recall, a while ago, I added those headings in. Anyway, if I want to see all the commits, I can click here, where it says 13 commits, and I can see just a visual representation of each commit. So here's where I began. Yeah, if you have multiple pages, like lots and lots of commits, you can go between pages, but this is my most recent commit. If I click, what do we see? Well, I just started with these two files, outline.txt and characters.txt. If I look at a different commit, how about when what did I do? How about removed extra blank lines in chapter 2? If I scroll down, you'll see highlighted in red, those are the 2 lines that were removed, and this is all that was affected, this one file, right? We see some other stuff, like when I renamed Gatsby to Catsby, lots of files impacted. You can see all those impacts here. This line changed, Gatsby became Catsby, and all these other files too. So I can see all those commits on the master branch. The most recent one is begin chapter 4. If I switch to empty, the most recent commit is delete most things, which in the last video you saw I deleted quite a few files. And on each of these commits, I see the commit message, obviously, and then I also see the commit hash. And then for some of them that have much longer commits, like this one, right, I can see the entire commit message. This is when I demonstrated, how to set up VS Code to make a commit message that's much longer. So I can see the whole commit message here, and then I can see the files impacted. And I can leave a comment if I want to. Probably not going to because I'm not collaborating with anyone. But if I want to, I can leave comments here and, revisit them and come back and look at my comments. But this is actually a very important part of discussing changes once you start working with other people. And that's pretty much all we need to cover for now. Eventually, we'll learn about things like pull requests and how to make pull requests, how to compare things. We are not at that point yet. That's going to come up when we talk about workflows. But yeah, that's pretty much it. Switch branches here, that's probably the most hidden thing that sometimes students miss. If you don't see your changes showing up, and if you have multiple branches, make sure you switch to the correct branch to see those changes. Okay, this video is just additional practice or reinforcement on the basic pushing workflow: add, commit, push up to GitHub, and repeats. So if you feel good about that, move on to the next video where I talk about cloning your own repos, option 2. But for now, I'm going to go back to my first novel, and nothing super exciting in here, but why don't we make a new branch? What branch are we on right now? We're on this empty branch. What would be a good branch to make? Why don't we go back to master? Okay, so I'm going to switch, git switch master, and I'm going to pretend to do some more work. We've got chapter 2, 3, 4. Why don't I remove this mood board? I'm just going to get rid of that. So I'm going to do an rm-rf mood board. So I got rid of that folder. I'll do a git status. I'll add all those changes. Git commit, delete, mood board folder. So now we have this new commit that only exists here locally on my repo, on my laptop, on the master branch, not up on GitHub. So now I'm going to switch to the empty branch, git switch empty. I'm going to make another commit on this branch. So what do we have in here? Not a whole lot. Why don't I make a new file? We'll call this one characters outline. How about summary.txt? And then I'm just going to add that empty file and commit it, add summary file. Okay, so now we have a commit here on empty that is not on GitHub, and we have a commit on master that is not on GitHub. So let's push both of them up. It's going to take 2 commands, right? We need to first decide, let's push up master branch or let's push up the empty branch. Remember the syntax, git push, and then our remote is origin. That's the only one we have. And then I'll push the master branch to begin with. Okay, so if I come back to my GitHub and I refresh, I don't see anything new here, right? Because I'm still on the empty branch on GitHub. I'm looking at the empty branch, but if I switch to the master branch, we can see this new commit 2 minutes ago, delete moodboard folder. And we don't see the mood board here anymore at all. So, I can take a look at that commit, specifically see what was deleted, as you see there, the whole mood board directory and its image contents. So that new commit was pushed up, whatever new commits existed on the master branch, but on the empty branch, nothing has changed on GitHub. Remember, on my local empty branch, which I'm on right now, we have this new file, summary, and we have a commit called, what was it? Add summary file. That was the message. So if I want to push that up, I need to do git push origin, and then the empty branch. And if we head over here, refresh at some points, here we are. Empty had recent pushes less than a minute ago, and we see summary.txt, that was pushed up, and the commit that it was associated with, add summary file, 2 days ago. So that's pretty much all I wanted to show you here, right? That basic workflow, do some stuff locally on a branch, make some commits, and then you push that branch up. And that about wraps up the basics of using the push command, right? We have a branch locally, we push it up with git push, remote, and branch name. Then GitHub now has that branch hosted in the cloud. And then we repeat that if we want to push another branch up. Now, you don't have to push, every branch you make up. Often what you'll do is have a master or a main branch, and then you'll have branches where you work on features. You can merge those into master/main and then push that new master/main work up. Or you can push branches up to GitHub and just have a whole bunch of branches. But that's something we'll talk about when we get to workflows. All right, in this video, I want to show you option 2 for getting your code up on GitHub or connecting a local repo to a hosted repo, starting from scratch. So this works if you haven't started your work on your project at all. You know you want to use GitHub, and you know you need a Git repo on your machine, but you don't have an existing project to push up. So we can start on GitHub. We can make a brand new empty repo on GitHub. So that's what I'm going to do. Then we clone that to our machine. So I'd make it on GitHub, clone it down, and that act of cloning it down automatically configures the remote for me. So then I can do some work and push it up. So this will be quick. Let's make a new repo. Remember, you can do that by clicking new or by going to the plus sign, new repository. I'll make this one, I don't know, how about chickens, chickens demo. Okay? And we can make it public or private. We will come back at a later point in the course to talk about README files. We've already talked about git ignore. So if you want to start with a git ignore file, we can do that on GitHub and clone that down. Or we can make our own git ignore. I'm just going to keep this simple and have an empty starter repository called chickens demo. All right. So now that I have this empty repository on GitHub, the next step is to clone it down to my machine, right? So we've made this repo on GitHub. There's no corresponding repo on our machine. We clone it down. So to clone, all we need to do is copy this URL, right? So I'm going to copy that, and then I'm going to go to my local machine. Let's back out into, let's see, just the GitHub directory I made. I have this cloning directory, sure. So in here, type git status. We're not in a Git repo. I'm now going to run git clone and then chickensdemo.git. And it tells me you appear to have cloned an empty repository. Okay, so we have a new folder called chickensdemo. There's nothing in there, but it is a new folder. And if I type git status, it is a Git repository. And I don't have any work to push up, but we do have a pre-configured remote called origin. So now I can do some work. Let's make a really simple file, touch chickens.txt. And then we can open that up and put something in there. So here it is in my editor. Let's put one of my chickens, Stevie Chicks, in there. And then the gray lady / lady gray, another one of my chickens. Anyway, we have some contents in there. I'm going to add and commit, pretend we've done some actual work. So git add chickens, git commit, add, my first 2 chickens. Great. If I refresh GitHub, nothing has changed whatsoever because I still have to push, as we've talked about. So that's the next step. I've done some work, not a whole lot, but I've done some work locally. Now we push that up. So it's the same exact workflow from this point forward. The only difference between what I showed you earlier is that we cloned an empty repo and started working in that repo versus our first approach was we've been working on something locally. We have a bunch of commits. I want to get those on GitHub. So I'm not going to clone an empty repo. I already have my repo on my machine. So I make an empty repo on GitHub and then I configure a remote so my local repo points to that GitHub repo. Anyway, I'm going to push. So it's just the master branch at this point, right? That's the only branch I have. In the next video, I'll talk about master and main, but I just have the master branch. So git push origin master. Just one simple commit. If I refresh, we see chickens.txt is here, and we have our one commit, just one. Add my first 2 chickens. That's all the history we have on this branch. So that's just another way of connecting a local repo to a GitHub repo. Different approach, but then the same workflow once we have that connection established. Do some work, add commit, and then use push. Okay, the last thing we'll talk about here is in 2020, I've mentioned this a few times, GitHub decided to rename the default branch from master to main. Now, we've seen that doesn't really impact us, right? We've been able to just push up a master branch, and it's defaulting here to showing us master. If I just go to this repo, we see master. However, I do want to talk about it. If we make a brand new repository, we'll just call this, how about colors, all right? Here's our repo called colors. There it is, colors. And I'm going to create this repository. And maybe this time I'm going to initialize it with something. So we'll learn about readmes, but I'm just going to click this box. And notice it tells me something different now, right? It says this will set main as the default branch. If I get rid of that, it doesn't say anything about main because there is no branch. So when I create this repo as is with no readme, just completely empty, there is no branch that is initialized. But as soon as I add a file to GitHub, when I'm initializing this repository is what I mean, it automatically needs to have a branch, right? You can't have files in a Git repo that are tracked and committed if they're not associated with some branch. So it defaults that branch name to main. So we could change that in our settings so that it always defaults to master, but more and more people are using main anyway, and that's kind of the push that GitHub is working towards here. So if we do this, I create this repository. Now it has a file in it. It has a commit, initial commit. That was made for me, right? I didn't say commit-m or anything like that. It just made me this README file, which is something we'll learn more about in future sections. So for now, it's just a file. And I'm on the main branch. So in order to get this branch down to my machine, or in order to work with it, I can clone this repository. So I'll copy that. And then I'll go over here and make sure I'm not in a repo. Git clone that URL. Okay, and then we have this colors repo, right? And if you look at the branch we're currently on, it's main. So this makes it easy. If we want to work on the main branch, we just clone it and we have the main branch. But something that you may encounter is some companies or some projects may want to rename their branch from master to main to be in accordance with these. They're not rules by any means from GitHub, but this new decision by GitHub. So to do that, if you've been working on the master branch and you want to rename it to main, it's just like renaming any other branch. So you can actually see instructions if you make a new repository. I'm going to delete this. But if we make a new repository, it shows us, as we've talked about a couple of times, what to do, right? It gives you instructions. If you want to push an existing repository, add a remote, and then this line renames the branch you're currently on to be main. Or here's another version of this. If you don't have a repository yet, make a new repo, get an init, add some stuff to it, commit, rename the branch to main, and then push your branch called main up. So I'll do this with our chickens demo. I have this master branch, but if I want to rename it to main, whoopsies, I need to go to that repository. Jeez, I can't type. Back out of here, cd into chickens, right? We have one branch, which is master. If I do git branch -uppercase M main, that renames my branch to main. So now there is no master branch, right? We just have main. Remember, there is no significance to the master branch name itself or to the master branch period. It's just that you have to be working on a branch in Git, and by default, the default branch name is master if you're working on Git on your machine. But on GitHub, the default branch name, if you clone a new repo that you have not created a branch on, but GitHub has made a branch, it will default to main. So don't get worried, don't freak out if you don't see master, right? It's this exact same concept. It's just a branch. And GitHub made this decision recently to make main that default name. So now I could push this branch up, git push origin main. And if we head over here, if I refresh, we still see the master branch, right? But now we see main. So there's main. You'll see though that master is considered the default branch here. That is because we pushed up master first. There was no main branch. And so GitHub doesn't ignore a master branch. I can change what the default branch is on this project, but really you probably would not have main and master in the same project. What you would have is either a brand new empty project, you clone it down and you start on the main branch, or you work on a project with your company or some team and they decide we're not going to use the term master anymore. We will rename to main, and then you can make main the default. I believe you go into settings, and then we have branches, and then I can decide that the default branch is actually main. And so now I've updated my project so that it defaults to showing me main when I visit my repository. So keep in mind through all of this, if you're confused, it's just a name. Master is just a name for a branch, and main is just a name for a branch. The only complication comes if you have been working on one branch called master and you change that name. If you change it locally, then you need to push up that new branch name to GitHub. And then if you care about what your default branch is on GitHub, you need to change that. But this is not, some seismic shift. It's just a branch name that you can change, and you'll likely see more and more people using main rather than master, though master is still incredibly common, and it's still the default branch name on Git. All right, so now it's time to get some practice on your own with the GitHub basics, creating GitHub repositories, setting up remotes, pushing, that sort of thing. So nothing crazy here, but really the bread and butter of working with GitHub is just getting your code up on GitHub. And then, as we'll soon see, getting code down, pulling down from GitHub, which we haven't yet learned. Anyway, as always for these exercises, you can find the link to get to these instructions as a resource with this video. So I recommend you open that up and probably, like always, just pause this video and read the instructions. If you have questions, come back to this video. So the core idea here is that you're going to make a new repository locally on your computer. Then you'll go to GitHub and make a GitHub repository. And then you'll connect the two. Then, after that, you'll make a file called favorites.txt, an empty file. You'll save, and you'll make your first commit. Now, this part is optional if you want to go with main instead of master. I'm going to be using main just to be consistent in this file, but if you choose to stay with master, then just sub that in wherever you see main. So you'll make a new file, favorites.txt, leave it empty, make your first commit on the main branch. Then push up that main branch to GitHub. So make sure that you see your empty file on GitHub. Then the next bit is to make two branches, a foods branch and a movies branch, both based on the main branch. Then switch to the foods branch, add 3 or more of your favorite foods to the file, add and commit your changes. Then switch to the movies branch, add 3 or more of your favorite movies to the favorites file, add and commit your changes. Then push up your foods branch to GitHub, and make sure you see it on GitHub if you refresh the page, and then do the same thing for the movies branch, push up the movies branch. And then we get to this step where I'd like you to merge the foods branch. Let me fix the highlighting. Okay, there we go. So you'll merge the foods branch into the main branch, and then you'll merge the movies branch into the main branch. So you should now have, after this step, a favorites file that contains both your favorites movies, both your favorite movies, and your favorite foods in the same file, favorites.txt, on the main branch. So now the main branch has changed. GitHub doesn't have that. So push up the latest work from that main branch, push it up to GitHub. So that's the basic steps, right? Make a repo, go on GitHub, make a repo, connect the two. Then push up your first little commit on the main branch, make 2 branches, do some work on both of them, push each of them up individually, and then merge those branches locally into the main branch and push the main branch up again. So please give it a shot on your own, unless you are very comfortable with GitHub. I don't know why you'd be watching this video anyway, but I know it's not the most exciting possible. I mean, none of these exercises are going to knock your socks off, but very important basic workflow. So I'll go ahead and do it. I'll make a new repository locally on my machine. Let's do it in a folder. I'll call this favorites. I'll cd into it and check that I'm not in a repo. I'll init a new repo. Okay, and then I'll go ahead and make my new GitHub repository. So go to github.com, click the plus, new repository, and I'll just call this one GH favorites exercise. Name it whatever you'd like. I'll keep it public if you want to take a look. There's not really going to be much to look at, but you're welcome to. And then I'm going to create it. And then the next step is to connect my local repo to the GitHub repo, which really just means add this remote. So I'm going to add that remote, and then optionally rename my master branch to main. We can just copy that, assuming that we're on the master branch, or in this case, we're not even on a branch yet. So I will need to make that master branch, or I will need to do some work, but then I can rename it. So as you can see, I'm not even on a branch yet. I don't have any commits, so there's no branch reference. But I'll just save that line for just a moment, because next we're going to make a new file called favorites.txt. We'll leave it empty and make our first commit. So touch favorites.txt. Then we'll add it. So git add favorites, and we'll commit. Just do something like add empty favorites file. Okay, so now we see master there, and I'm going to rename that to main. Right? So I type git status. We see on branch main. If I type git branch, we don't have the master branch anymore. So if you want to go with main, that's how you do it. Next, we need to push up this main branch to GitHub. Right now, nothing is up here, it's just empty. So git push origin, if that's the name of our remote, and you can always check git remote -v, it is origin if you just copied and pasted from GitHub. So git push origin, and then main is my branch. And if I refresh here, we should see that empty file, and there it is. Okay, so next step, we need to create two branches, foods and movies. So git branch foods, git branch movies. Or I could do git switch -c or git checkout -b. I can switch to one of them, so I'm going to switch to foods, if I can spell that. And then add 2, or what did I say, 3 of my favorite foods to the favorites file. So let me open this file. And what are my favorite foods? I did not think through this at all. Well, one of them would have to be peppermint ice cream, not just mint chip. It has to be peppermint ice cream. It's not that common anymore. Used to have it around Christmas as a kid. What else? Man, I'm going to sound like such a fatty if I just say my honest favorites. Soft pretzels. Oh, I love soft pretzels. And then I feel like I need to just lie. How about celery? Yeah, I just love celery. All right, so now I need to add and commit this on the foods branch. So git add favorites, git commit -m, add favorite foods, not dudes. And then that's it. I could skip ahead and just push it up, but I'm going to now switch to the movies branch, git switch to movies, and add 3 of my favorite movies in here. If you've seen any of my other courses, you probably know, or at least maybe you might remember my favorite movie is Amadeus. I think I say that far too often in my courses. Great film. You got to watch it if you haven't seen it. And if you don't like it, I get it. It's not for everyone, but anyway. How about Fifth Element? That's another one I like. Not necessarily, this is not top 3 movies, not in order. It doesn't matter, okay? It doesn't matter at all. What else? Here's a fun one I liked quite a bit. Captain Fantastic, Viggo Mortensen. Sure, we'll say those are my favorites. Not quite. Amadeus, though, yeah, always number 1. Okay, so now I'm going to add those changes. Git add favorites, git commit, add 3 of my fave movies. Okay, and then we get to this step. Push up the foods branch to GitHub. So I can just do git push, my remote origin, and then the name of the branch, foods. I don't need to be on the foods branch. And I'll refresh, and we should see a new branch. There it is. And we want to verify we see our foods. Whatever you put, they show up here, right? And I was looking at that file, so that's why I saw this view. You'd probably see this. Okay, now push up the movies branch. Git push, origin, movies. And refresh. Okay, we see the movies branch, and there we are. we see favorites, and it has my favorite, or some of my favorite movies. Then finally, merge the food branch into the main branch. So I'm going to switch to main, and then I'll just show you my favorites file is empty right now. And I'm going to merge in foods. So git merge foods, and that's just a fast forward. Okay, that's the easy part. Then I need to merge the movies branch into main. Now this won't be a fast forward because now there's commits on the main branch that the movies branch does not have. So git merge and then movies. And we get a lovely conflict. I'm just going to select accept both changes, and there we go. We'll just leave it like this. I could put a little heading, I guess, if I wanted, that said movies here. Meh, I'll just leave it like that. Anyway, I'm going to resolve the conflict like I just did. I'm going to add favorites, and then I'll make my commit here. What should I do? Let's just clear git commit, merge movies and foods into main. Okay? And then finally, I need to push that up, right? So I don't have that latest commit on the main branch on GitHub. If I go to it, it's just an empty file. Very sad. Now, it's just as simple as git push. Now, I didn't use -u in the previous, when I first pushed the first time, so I still need to say origin main. If I had used -u, I could just say git push. So, actually, it might just figure it out on its own. No, it does not. Okay, so git push origin main. And if you have questions about that -u, there's a standalone video I made on it, so you could go check that out. But you probably already know that. Okay, and there we are. So we see that we have this new commit 1 minute ago, less than that, where we merged movies and foods into main. And on main, we see all three on GitHub. Foods just has the foods, and movies just has the movies. Okay, I need to take a break and watch one of these. That would be nice, with some peppermint ice cream and pretzels, and not celery. I don't like celery at all, really. Bye-bye.